Alright, this is 211 Notes, Part 4. Now that we could do 2 on 1 graph, it's time to do this on a diagonal line. So we're going to apply what we've known in the other parts, what we learned in the other parts, and we're going to apply it here to Part 4. So we got the same situation going on here. Point Q lies on the green line. So this random point Q that we're going to try to find falls somewhere on line AC. Our line segment AC. If AQ to QC is the ratio of 2 to 7, where is point Q on the line segment AC? So the ratio 2 to 7 is the information that we need as of right now. The ratio 2 to 7, well, you take that first number, 2, and divide it by the total amount. So 2 plus 7 is 9. So Q is 2/9 of the way from A to C. So that's that ratio converted into a fraction for us. Now, from the bottom of endpoint A, what we were doing before, we did the ratio, we applied that 2/9 to the distance of AB. So just let's find that distance one more time by counting boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So the length of AB line segment is a total of 9 boxes. So we're going to do 2/9 times the total length of AB. So 2/9 times 9 is equal to 2. So from A we go 1, 2. That's where the horizontal length from A to C is going to be right there. Now how far down do we need to go? Well, we got to count the boxes going down. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, it's also 9. That's nice. So it's going to be the same math. The 2/9 from our ratio times that total distance of 9 also equals 2. So in addition, going from to the right 2, we're also going to go down 2. So point Q is a coordinate right there. It's a coordinate -8, 8. So Q is a coordinate -8, 8 on the graph. Alright, let's do another one. So looking at this one. Bring it down a little bit. There we go. Point Q lies on the green line, just like we did before. AC, if AQ and QC is 3 to 6, where is point Q on line segment AC? So we're going to find that coordinate where point Q is. So from the bottom end point A. So we're going from A to C. AQ to QC is a ratio of 3 to 6. Ratio of 3 to 6 turns into 3 over the total. Well, 3 plus 6 is 9. So we 3/9 times the distance here of AB. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 once again. Since that has a distance of 9, we do 3/9 times 9. That's going to equal 3. So we go 3 to the right. 1, 2, 3. Now we got to find out how far down we got to go. So 3/6 is the same fraction, 3 over 9. The distance from B to C is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's also a distance of 9. So 3/9 times 9 is also equal to 3. So in addition to going to the right 3, we also got to go down 3. Let me find that position. And the coordinate is -7, 7. So the Q coordinate's at -7, 7. It's the location of Q. Alright, let's do another one before we change the location here. So you can see it's the still same setup of a triangle, however we're just changing up the ratios to start with before we start moving the triangle like crazy. So the ratio is 2 to 1, so it's 2 over the total, which is 3. So 2/3 times the distance here. So the distance is 1, 2, 3, 4, 5, 6, 7, 8, 9. I bet that's also 9 also. Just to confirm. Yes, it is. So 2/3 times 9. 2/3 times 9 is 6. So we have to go right 6 from A. 1, 2, 3, 4, 5, 6. Why am I counting from A? It's because they're saying from endpoint A. Two-thirds times the distance of 9 going down is also 6. So we go down from this point. 1, 2, 3, 4, 5, 6. That's the location of Q. Right there. It's at -4, 4. That's where Q is. Alright, let's move the triangle a little bit so we can see it a little bit different of a problem, but nothing too far different. So it's the same question. It's phrased the same way, that is. Point Q lies on the green line AC. If AQ to QC is 2 to 3, where is point Q on line segment AC? So the ratio, if you got 2 to 3, so we take that first number 2 and we divide it by the total. 2 plus 3 is 5. So that's the fraction that we're going to be multiplying with. Where is Q on line segment AC? From the bottom endpoint A. So we're going from A. So from A to B is 1, 2, 3, 4, 5. Since that's a distance of 5, 2 fits times 5 is 2. So we're going 2 to the right. So 1, 2. Now how far up? Well, we do the same fraction. 2 fits. We count how tall this blue line is going up and down. B to C is 1, 2, 3, 4, 5. So 2 fits times 5 gets us also 2. So from here we gotta go up 2. And that's the location of point Q on the green line. It's a total of 4 to the right and 4 up. So the coordinates at 4, -4. Let's do another one. So the ratio is now 1 to 4. Well, 1 to 4 is the same as the fraction 1/5. Just take the first number in the top, and then the sum, 1 plus 4, is 5. So I get the 5 there. So 1/5 from endpoint A. So this is once again a total of 5. I'll just write the 5 there. That's the length. So 1 to the right. Because 1/5 times 5 is 1. So this is why I went 1 to the right from A. Then I gotta do 1/5 times the height, which is 1, 2, 3, 4, 5. 1/5 times 5 is 1. So the height, we gotta go up 1. And that's the location of point Q. It's 3 to the right, 3 up. So 3, 3 is the coordinate for Q. Alright. Why don't you try this one on your own, and I'll fill it in. Give you a minute to. 3 to 2. If you got 3 over 5 as your fraction, very good. Find the distance. Once again, this is a total of 5. So 3/5 times 5, which gets you 3. So we go 3 to the right. 1, 2, 3. The height. 1, 2, 3, 4, 5. So 3 up. That's the location of Q. It's 5 to the right, 5 up. And that's the location of Q. And this one's a little bit different, so. But you understand the principle, so try it on your own first. Alright. If you didn't hit the pause button, you hit the pause button to do it, but now I'm going to start doing it. So 2 7s turns into 2/9. Find out the distance. 1, 2, 3, 4, 5, 6, 7, 8, 9 is the length. The height is also 9. So 2 9ths times 9 is 2. And then 2 9ths times 9 is also 2. So you go 2 to the right, 2 up. So you have -3, -2. Alright. Now, what if the leg lengths are a little bit different? So let's tackle 2 problems like that. So point Q lies on the green line AC. If AQ and QC is 1 to 2, where is point Q on line segment AC from the bottom end point A? So going from endpoint A, the ratio is 1 to 2, so the fraction is 1/3. Find the distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this has a length of 18. This has a length of 10. So 1/3 times 18 is 6. So we got to go 6 to the right from A. 1, 2, 3, 4, 5, 6. Made a little red dot there. Then we gotta go 1/3 times 10, which gets you 3.3. Now it's okay to have a decimal. That's gonna happen. So 3 1/3. So you gotta go up from here. 1, 2, 3 1/3. Ideally, that decimal is gonna hit the line. So all you gotta do is find out where they're intersecting, right there on the line. And that's point Q. So point Q is at -4, -4.6 bar notation. So -4, and it went down -4 point, and then 2/3 of the box, which is 0.6. And that's the location of Q. So you can see it's the same process, even when the sizes of lines A and B are different. Alright. So, if you have any questions, please feel free to email me or come next job after school. I'll be happy to help you out. Alright, have a good night.